Let's take a quick look at this question. This question will ask, which pair shows an unexpected trend in electron affinity? Now, before looking at the various options, what do you understand by electron affinity? Electron affinity is simply the energy that is released when an electron is added to a gaseous atom. It is opposite of ionization energy. Now, electron affinity increases across the period and decreases down the group. But there are some exceptions to it. That is why this question is like this. Now, in this question, we have various options: lithium to carbon, carbon to nitrogen, nitrogen to fluorine, and lithium to fluorine. Now, let me explain the concept. Whenever electron is added to a gaseous atom, there is always a release of energy, which is what? Exothermic. If you look at lithium here, look at the electronic configuration of lithium. Look at the electronic configuration of lithium. Lithium is in the 1s orbital and 2s orbital. So you needed electron to be added here. But in the case of carbon, carbon is in the 1s orbital, 1s. Now look at the electronic configuration of lithium and carbon. We release most here because the energy level here is higher than that of the lithium. Lithium you are adding, so energy will be released. What you are, anytime electron is added to a particular subshell like this, heat is being what? Released. But both of them require one electron to be added here. This one will completely be half filled. This one will be fully filled. So this one will require more energy because of what? It is in a higher orbital, higher subshell. Now it increases. Look at it increases because this one will require carbon will require more energy than this one. Let's go to the second options. Carbon and nitrogen. We all know that let us know the electronic configuration of nitrogen. Nitrogen is 1s, 2s, and we have 2p. Now this is the electronic configuration of carbon. Now in carbon, now the next, what are you going to add? The next, if you add another electron, will balance this one, so there will be enough heat that will be what? Will be released. On the other hand, we have nitrogen. Nitrogen here, the next electron you are going to add, you are going to pair with this one. According to a Horn's rule, you are going to pair with this one. Therefore, nitrogen will tend to be what? To have an electron repulsion. There will be electron repulsion. Do you get that? That is why nitrogen would rather be what? Endothermic than what? Exothermic. Therefore, instead of increasing across the period, it will do what? Decrease, because the energy, this one you require to add electron here, and if you add electron here, this one there is a vacant space here. So if you add electron here, more heat will be what? Will be released. But this one now, you are now pairing, and when you pair now, there will be electron repulsion. That is why there is lesser heat that is being released. So therefore, here will be exothermic, and here will rather be what? Be endothermic. That is why there is an unexpected trend. Unexpected, instead of increasing across the period, is rather what? Decreasing. Do you get that? The energy that is released here is in carbon is more than the energy that is released in what? In nitrogen. Of course, we know that nitrogen and fluorine will need only one. That is why the amount of heat that is being released when fluorine, all these electronegative element gains electron, is very much. You get that? So this one need electron, one electron, so that it can be what? It can be stable. That is why the amount of energy is very high. So nitrogen and fluorine. Nitrogen, of course, we have said that it will require what? Are you following? Likewise, lithium and fluorine, we have already illustrated the word of lithium, and fluorine will need more. So among all these options, the electron affinity will nitrogen. After nitrogen, we'll have carbon. After carbon, we'll have what? Fluorine. This is the order of what? Increasing electron affinity.